Well, hello, welcome back. Um, I'm really looking forward to this session. It's our final session on the observability and security stream, and I'm thinking we've saved the best to last with this. Um, I absolutely love your description, Marcin. I've been that man faced with a 3,000 line bash script, and I didn't run to the mountains, but I did fold in a heap on the data center floor, trying to figure out where to start with this horror show while our entire site went into meltdown. And you urge us not to grow grey hair anymore. For some of us, it's already too late. This was my experience. So, Marcin, you're here to give us hope that Bash can even be functional. This I have to see. So please take it away. Over to you, Marcin.
Thank you, Finbar. Let's see about that. Hello everyone. I am Marcin Stozek. I go by Perk everywhere on the internet wherever I can. I work at the Sumo Logic company that gets your data and do some cool observability stuff about that. And I will be talking about Bash. And this is very interesting presentation for me personally because this is blood and sweat. And whenever I talk to people about this presentation after the presentation, they say like, oh, we have the same memories, you know. It's very interesting that we do have the same problems, like actually everywhere. And because of those conversations that I had in the past, I decided that okay, so we just need to create this. But I call this presentation that this is a meeting for the AA. Like everyone writes Bash, and we all think that we should do it properly, and somehow it does not work so well many times. So we should just talk, about that. So let me start with that. So I'm Marcin, and I wrote too much Bash in my life, maybe more that I should tell you about. But we'll see. Work is no disgrace. Sometimes you just have to write Bash scripts. So let's see about that. But let me start with a story. Let me start with this single line, which is which is actually funny and scary at the same time. It is easy, right? So you have a schema root, then you have a very weird string, then you just go to a directory, you echo something, right? It's absolutely necessary to have this comment here, because without this comment, we would be lost, wouldn't we? I mean, there are people who can read that, but myself, after spending quite a lot of time with Bash, I would need to go to the manual for that. So, it's very good that the comment is here, but the problem with this is that there is a slight bug in here, and actually, in the link below, in the description, there is a states that we I had a problem with this line, but because I ran this script twice and I moved the directories in between, and now I don't have my backup, which was like 3 terabytes of memory. Dear Valve, what is going on here? And guys, I think that it is for me right now. This is pretty simple, but it may not be for you. The problem here is that it should work, right? You have a Steam root, which is directory. You just delete all the files which are in the Steam root directory. But what happens if this variable is empty? Then you just delete all the files on your root file system. And if you just use the no preserve root as well, then gone, you don't have any files at all. Why? Why do we do it for to ourselves? We should stop doing this actually. Okay, but let's start from the beginning. What is Bash? Bash is a shell, right? Everyone knows that you can open up a console and you have a shell. That is a command processor. You can have Bash, you can have Z shell, you can have Thompson shell, and some other shells. But the most important thing about all of those is that those command processors, those use the command language. This is like subtype for our scripting language. This is a DSL domain-specific language to control jobs, so that you write a command, you run a command, and you get an output, and you get some, return codes as well. It is Turing complete, so you can write everything in this, but then you don't write like operating systems in JavaScript, and you shouldn't do that in Bash either. But you can, actually, if you are brave enough. You can ask Bash about it, about itself. There is this command that's called what is, and you can ask like what is Bash. So let's try, like, just type what is. So it says like what is what do you mean? So let's ask about Bash. Bash is a reimplementation of a shell of a shell from the 89, and originally that was Thompson shell and Bourne shell, but at some point, guys from the GNU project, they decided that they have so many scripts that they need to actually implement their own shell, and hence Bash was created. And now I need to mention that this is actually important here, that I am talking about Bash specifically. I'm not talking about the other POSIX compatible shells, and that is, for a reason. I personally think that we rarely write scripts for other shells. Personally, when we are developing some applications right now, everyone is packaging their application in a Docker container, for example, and we do know which shell is there. So I decided that, okay, so let's use Bash, because I think that it is widely used. This command is particularly interesting because you can ask about some other languages as well. So let's do that. Let's ask about JavaScript. I will leave it as that, because that's not me, that's Bash. Go ask your console. Everyone likes writing Bash scripts, right? How do they look at the beginning? They are very, very short and brief. We love them, right? They are just a little bit scary, but not so much. Just a little, a couple lines of code. Then after some time, we add another couple of lines of code. And after some time, we have this like enormous big beast, right? Magnificent. We are scared just a little, but is that true? I question that. Is that correct? Because I think not. I think that this is more correct, actually. So I'm pretty sure that our Bash scripts is rather like that and not the other way. I'm sorry to tell you that. Let's see how to tame this beast. So let me start with this variable in Bash. Because some might say that there is a variable, and I mean that the variable has a type. The variable in Bash, that it has a type. Okay, you can say that, but they are actually untyped because they are variable, that they are character strings. You can say that Bash is stringly typed. Every variable is string. And I think that you have to have that in the back of your mind, because that helps a lot. Sometimes when you have some digits in the strings, you can do some arithmetic operations with those strings, but that doesn't help. And also you can have arrays, but they are not so handy. I would say. I mean, sometimes you have to use them, but they're not so nice to use. So let's focus on those strings inside variables. And then we have those $sign variables. You know that when you write your Bash script, or you just type some commands in the console, you have those variables that are just there waiting for you. And I think that it is important for me to say what are those. So first of all, you have those positional parameters. This is $1, $2, $3, and so on. These are parameters that comes to the function or to your script. If you have variables that are coming to your function or to the script, to get those, you just use those positional parameters. Also, you get the number of parameters. You get the expansion of those parameters. you can have the expansion with just space, or you can have an expansion using the internal field separator, which is a special variable in Bash. Also, you can have the name of the script, the PID, process identification number of the current shell, the PID of the last command, and the last command's exit status. And now let's go to the details. What you should do and what you shouldn't do, actually. So on the left, don't do that. On the right, do that. You should always use quotes. I mean, whenever you do echo and you don't use quotes, something bad might happen, and you can see this in the example. So first of all, in the first line, in the Y section, you have a variable that is called 1, 2, and then there is asterisk. So that's fine. We have a variable which is a proper one, and then we echo this variable. So whenever you echo this variable using the quotes, it's okay, because you get what you thought you will get. But whenever you echo without quotes, then Bash starts interpreting this, and it will just say every through every element. So first is 1, that's fine, okay, so it says 1. Then it's 2, it writes 2. Then it's asterisk, and in asterisk, in Bash, asterisk means that every file which is in this directory. So it just writes every file which is file and the directory which is in the current directory. So we have 1, 2, bin, boot, cd-rom, and so on. Whenever you are on the root file system, so you should actually use quotes, because without them, you will just have problems. Then the second one, no space, around equal. That is because in Bash you just write, like on the right, language equals W without space, and that's how you do it. If you do it differently, then it just have a different meaning. So in this example, in the Y, you can see that I wrote foo space equals space bar, and we got like that this thing, that command not found. Why is that? That is because Bash tried to run the foo command, and it's not there, right? I don't have a foo command on my computer. Maybe you do, so it would work, but usually it will not. Then we have another example. There is this command called env, and env prints all the environment variables. So whenever you pipe, you can search for a specific variable. Here I search for the bar variable, and it's empty because by default there is no such variable. Then in the third line I do the same, but I first say that, okay, so foo equals bar. That means that I will pass this variable to the env, and then I looked for this for this bar, and here we have it. It's there. This is called this is very cool thing whenever you wanna like hack around with some other programs, because here I use just foo equals bar, but you can use some other environment variables that will be attached, that will be passed to your program, and especially there's this one which is called LD preload. And whenever you use LD preload, that means that you can attach some other libraries instead of the official ones, and do some hacking around. So you can change the loaded libraries on the fly. That's really cool. Okay, assignment codes. And what I mean here, you should, as I said before, you should always use quotes, but also for the assignments to the variables. As we can see on the right, you just use quote, and then you have everything in your ownership variable. And why is that? Because when you write it without quotes, then what Bash tries to do, first of all, Bash tries to, it sets up the ownership variable to Allah. Then it tries to run command has with 2 parameters, a cat, and I don't have a command that is called has, so it doesn't work, obviously. So you just use quotes, and then everything is fine, as you can see in this example. and you should just do that. Immutable globals. That is a very nice thing to do actually when you do write your bash script. You can use this read-only to make your variable read-only. That is a very cool feature. It helps to make your variables constant, which is actually a very desired state for some of them, for some of those, if not for most of those, actually. So there are some, other things that you should actually do with globals. That is just, a rule of thumb and something that just helps you. You should just keep them to minimum, actually. And it's nice if you use like a uppercase format for the name of those global variables. And you just make them read-only so that no one can change them later on. That helps a lot. That will help, your colleagues and your friends who need to tackle those and work with your bash script later on. And they will bug you less if you do that. This is a nice one. You can name the parameters actually when you use them for functions, for example. And this is maybe just a little bit weird how to do that, but I think personally that if you have to have like long bar script, I think it's helpful. So in this don't, we just have a simple function that is just called list files. There is a problem with it. The problem is that you have to go through the invocations of the function to see what this $1 means, or actually know what this find command does. If you don't, then it's not helpful actually. And in the do section, as you can see, it's the same function. I just added the variable called type. So now I know that this function gets a variable called type as a first parameter, and by default this is the TMP. So it just reduces the cognitive load that I need to use to parse this function, in my head and know what is going actually, what is it doing with it afterwards. The next one, know your args. So there are don'ts and do's, and actually in the don't section, this is something that is used many times. This is something that you will see in the bash scripts, that whenever you would like to go through all the parameters that were passed to your script, you just do this in the loop with a shift. So you get first parameter, you read it, and you shift this whole table. So now your second parameter becomes first parameter. So you again read the first parameter, you assign it to something or do with something, shift. Then again, your third parameter that became second, now it become first parameter. So you read it and in the loop. The problem with that is that those variables are gone forever. So if your colleague would like to use those parameters somewhere else in the same bash script later on, they just cannot do that because they are not there. So this is an example how to do it without losing those parameters. On the right on the right side, we just put all of those parameters in the args table, and right now we can actually use them and we can reuse them. They are there for most of the time, that they will not be gone. So I urge actually, if you have like a complicated bash script, to use this form. And here I have an example for that. So we have 3 invocations and we have 3 functions, right? And for every all of those functions, I try to do the same thing. So I call the function fun with 2 parameters. First parameter is 1, and the second parameter is 2 space 3. And here it might be silly, but if you use I don't know, if you run your bash script on Windows, because you can now, and you have a space in your file name, then this is very important, because space might create problems for you. And here you can see what I do with this args command. Sorry, args variable. If it is just set like for f in args without any quotes whatsoever, it will just go over every parameter, but it will use the IFS to expand those, and by default it uses space. So it will use 1 space 2 space 3, and as you can see, the result is 1, 2, 3. That is not something that we intended to. The second one is that I use the same variant args variable, but with quotes. And right now I have an even different result. I have 1, 2, 3 in one line, which is not something that I wanted to have as well. In the third example, I have a declared declared args variable as array, and then I just go through all the elements of this array. And when I do that, I have a result that I intended to have. So you just use array as array, and you should be good. Okay, the next one, use explicit paths. This is something that is easy. Maybe it's controversial. Personally, I think that you actually should use the explicit paths because it helps. First of all, for example, sometimes it doesn't work because bash, for example, if you want to delete like too many files in a directory, you have the directory with millions of files. Bash will not be able to delete them if you just write rm and space then asterisk, because it just, the list is too big. So you just need to use some other ways to do that. And other ways to do that is just to use, for example, find, for example. Yeah, and with find you can add the delete command as well. But also, many commands would just behave better when you use the explicit path, because they don't have to think whether what is with this name, whether this is a name with a path or is it not. This is from my personal experience when I do this, when I use it this path explicitly. So I just don't say file. I said this file in this directory. That means this dot and slash. This is current directory. Then they just most of the time doing better. This is okay. Let's go to those ones. Those are subshells. We can see that you should use actually parentheses, those round brackets with the dollar sign, instead of backticks. And this is interesting. Those characters at the end of the topic are backticks. They are not single quotes. Sometimes you just say, oh, let's use backtick and do something, and then someone else is like, oh, what is a backtick? Where do I have a backtick on my keyboard? It's on the upper left command, upper left corner of my keyboard. It's a different character from the single quote. You can use backticks in Bash, but it's not so nice. Backticks, those are legacy. They are harder to read. You cannot nest them. And it's exactly the same as the dollar and the brackets. And with dollar brackets, you can, for example, nest one command inside another, and it helps sometimes if you have a bash script that has a couple thousand lines of code, which I don't think it's a very nice thing to have, but if you have to work with that will be helpful. Those are another types of subshells. This one is a one that does not give you the result. Just doesn't return anything. But it's helpful as well. And why actually subshells are helpful in the first place? That is because sometimes you just have to have some change in a single line. You don't want to change the script itself. You don't want to change any global variable or any variable at all. So for that, you just can use a subshell. So for example, here in the don't, you can see that I have a var backup because I need to back up my variable, then change the variable to the variable var to something else, then bring the backup back. That's not nice. If you need to do that, if you just need to change the variable just for the one invocation of of the other command, you can see it on the right. You just use parentheses. You change the variable first, then you echo your variable, and then outside you're just back to your value that was set before you did anything within the parentheses. So that's a nice one. Okay, now this about pipelines. Like this is actually about Bash, right? And about writing in Bash. And this is the thing that you just do. You just use pipelines because it's so handy. You just run one command, then you pipe its output to another command, then you pipe its output to another command, and it's all nice if you have those in one line. Yeah, like I mean, you can write those in one line. I think that you should not, because it doesn't look like that, in the real life. In the real life, you have something like first there is a find, then there is a grep, then there is some CURL, then there is like another find, and those are commands with some variables, with some arguments. It's just a lot of code. So it's easier to read when you put them stacked, like one after another, and not next to each other. So you can actually do that. As you can see on the left, in the do section, there's like command 1 / pipe in the next one, again command 2 / and so on and so forth. And on the right side, we have something that is slightly different, because I use double pipes or double ends, and this is interesting because this will work. Actually, you can do this kind of things in Bash. So you can run a command and then run a second command and then run a third command, and if any of those commands will fail, this execution will just stop, and then it will just run the fourth command. But this one is tricky, and that is because your commands, you have to remember that those are like with usual applications. Those applications can write something to the standard output, and they actually have an exit code as well, right? And those commands, whether those are Bash functions or just some applications, they do the same thing. But the problem here is that for Bash, this might be confusing because for Bash you sometimes work with the output and sometimes work with the exit code. On the left, you work with the output, because when you pipe, you work with the output from the command 1, then to command 2, then to command 3. On the right, you work with the exit code. So you have to be careful with that, but it is doable, and it is helpful once you know what you're doing. Also, there's one another thing that is good about this type of writing, is that whenever you do a git diff and then you change something in only one of those commands, then this diff is much easier to read. Then you can see, okay, so I just change something in this third command invocation. I just change one parameter, and you just don't get like this full line, and then you go through it at the very end to see like, okay, so what did they change actually, and for which command. Here it is much easier to find out. Here we have conditional expressions from the pure Bash Bible. This is very cool because sometimes you just don't have you don't have those external applications. So here I just show you that you can do many things within the Bash itself. So you can, as you can see here, do many things with the strings. You can do interesting things with files, but those are boring. And then in the Pure Bash Bible, this is it's like a lot of examples how to do things and not go outside of Bash, because you don't have to. The one caveat of that, the one problem with that is that those are not that readable. I might say that those are tricky ones. If you use those, please make sure that you know what you're doing. And the controversial one, because I say controversial because people sometimes say that whenever you write a script, it should be portable, right? Because you write a bash script, but what if you would like to run it on Solaris, and what if you would like to run it on HPUX, and then you're screwed, or you just use a Thompson shell or something. I think that it is actually better to use Bash itself, and whenever we use Bash, let's use the testing extension of it as well. The difference between the double bracket and the single bracket is that the single bracket is a command, which is test, and you can actually find it in your Linux distribution. It's just a program, and the single bracket is a Bash extension that do more or less the same, but in a much, for me personally, in a much better way. So let me show you let me tell you about those two examples in the don't. So first one is just we have wrong quotes here because we test whether whether the variable file is equals to the bar, and this is wrong because quotes should quote the file variable and not the bar itself. This might blow up, but that is easy. Let's take a look at the second one because that is even more funny. So here we check, right? And you tell me, do we do that? Because the way I read it is that I check whether 1 is greater than 2, and that should be false, right? And that is wrong. That is not what you think it is. You do not check whether 1 is greater than 2. Here, if you use the single quote, what you do is you check whether string 1 exists. And it does, right? Because you have it, it's not empty, right? And then you check whether your file system is not read-only, because this greater than 2 is just, redirection to the standard error, actually. So you check whether you can write to the file called sorry, this is not a standard error. This is a standard out. But you redirect to the file called 2 on the local file system. So if your file system is read-only, you cannot do that. So you check two things. First, if 1 exists, it does, and then whether your file system is not read-only. This is crazy. This is crazy. It could be lexicographic check, but it would need to have a backslash before this greater sign. And you can see it in the example. If you use the double bracket, then it just works. And as you can see, and please don't take my word for granted. Please check that in your console. You will have funny results using single brackets and double brackets. And now, this is important one. You should use functions. You should use functions because functions are there in Bash, and this is important because most of the time, and especially in the Bash script, you are not interested in what am I doing, here. But sorry, I am interested in what am I doing, and I'm not interested how am I doing it, right? So if I have a function and this function has a name, then I know that, okay, so this function just deletes temp files. I just don't have to go into that. And Bash allows that because you can use functions, and that is actually cool. And then, it helps as well because this is like, with functions, when you write a script, it is being written, and then it can be read as well. That is not true for like Perl or something, not for most quite a lot of languages. And here and for Bash either, but when you use functions, it helps here. So for functions, it helps because you can use the local variables. And I don't know if you know that, but every variable is global in Bash. So that's not nice. And when you use functions, you can use the local world, and then those variables are local. The code is easier to debug. Those are the things that we all know actually. Code, documenting code, and going through the code flow. I know where my main is and so on. So let me show you this local. When you add a local, as you can see on the right, to the variable, then this local does not go outside of the function. So as you can see in this example, I have two variables, mech and blach. And blach is a nasty global because it doesn't have a local. Mech is nice local. Then I run this function, and I echo both variables mech and blach shows that it is nasty global. So outside, even I am outside of the function, it has a value. It didn't have it before I called this function. But what about the nested functions and this local? Does it work like that? You got me. It's not so nice. It doesn't work actually. It sort of works. As you can see here, we have two functions, and I call another function inside the other. So within the function one, I call the function two, and I have a local variable which is defined in the function one. Unfortunately, this will pass along, and you have a variable, in the sub functions. So it works, but kinda. But with that, you can use actually the main function, and it is helpful. So you can have local for most of the local variables, but they are not so local when they are available in the sub functions. But let's not talk about that. You can easily locate the script's entry point, and that is cool because you go to the script, and you don't have to go through all this script listing and find, okay, so where the script starts actually, because I define somewhere here, then I define somewhere here and there, and then, oh, okay, so this will execute, and then you have another definition, so, and this will execute. You don't do that. You just define everything in the function, and at the very end, you define a main function which calls all the other sub functions. This helps a lot. But if the script is very short, I wouldn't bother. But now, okay, so we have functions, right, in Bash, and maybe if you have a function that can call another function, let's see, maybe there is a a functional Bash. And here, actually, let me show you that it is actually working. Those are real examples from real life of the higher order functions. There are two functions, and they are just outputting strings. Two functions, stało and stał. And we have a third function called co and the third function is just a decorator. It just adds some strings at the beginning and at the very end. And as you can see in the invocation down below, I do it like that. I called first function, which is co, and then I pass the variable, but as a variable, I pass the name of the other function. So I pass the function stało, and then I pass the function stał. And as you can see, those strings are decorated. They have those signs at the end and at the beginning. So it works. And how do I do that? I just use eval. I just use the sub shell to call the variable, but the variable, expands to the name, and then this name is a function. So it is just doing an eval. I know that this is eval, but we are talking about Bash, right? So sorry about that, but you just need to have just a little bit of that, especially if you want to do those kind of crazy things. But let's go further. Let's not stop with that. So there is a Bash monad, right? Everyone's interested, okay? I believe so. So here we have it. Pipe is not a pipe anymore. We have it is an this operator equivalent, and it is a part of monad. And frankly speaking, I don't understand it much, if you ask me. But I found two links that people are saying that this is the case. So I believe them. You can go check yourself. And for me, this is mind-blowing. But this functional bash works. And I just have to say that I was working with this very, very long bash script. After applying all of those things and using just a little bit of this functional bash, this script was in a very, very good shape. I got a feedback that people who do not write bash on a daily basis, they could actually change something and were not afraid that everything will just blow up. Okay, but let's go to another rules. We have an unofficial strict mode, and as you can see, the strict mode is EOU pipe fail, and then we change the IFS, this thing that will split our strings by default. So for E means that we will exit on every non-zero exit status. So if any of the comments that you run throughout your bash script will fail, then your whole script will fail as well. That is handy. Also, U means that bash will check for any undefined variables and will just say that, oh, there is an undefined variable used. You probably didn't want to do that, so I will just exit. And also pipe fail is the same as the -e, but -e, but for things in pipe. So if any command within the pipe, if you have like one command pipe, second command pipe, excuse me, third command, if any of those fails, then it will just exit. And the IFS, why we change the IFS? That is because most of the time, whenever we use this, file globbing, whenever we use an asterisk, we do not intend to split strings on space. And by default, this is new line, tab, and space. Actually, this is space, new line, and tab. Most probably you do not intend that. So I think that it is better to just change it to the new line in the tab. You can clean after yourself, especially useful with the set -e. You do that with a trap. So you just write a trap. You say which function needs to be executed and on what. Then so here I said that I should run a function cleanup on exit, and it will be run on exit. It helps whenever you have AWS script running. You can just have this function exit, and it will just bring down all of your EC2 instances.
So, Perk, I almost don't want to interrupt, but I'm aware we're into the last couple of minutes, and I didn't know if there was a summary screen or a contact screen that you wanted to leave us with. Because we're going to have to cut off in 2 minutes' time. There's so much good material here. I wanted to give you the chance, if you've got a summary screen or a contact screen to leave us with.
Sure. Yeah. Let me find. Yep. At the end.
But that was fabulous.
This one is at the very end.
We got to the
use Python instead.
Brilliant. I was going to ask that question. There you go. You answered my question.
Oh, sorry. Yeah.
That was the main question that I certainly had, is, how do we understand where to do this? Brilliant. Absolutely fabulous, Perk. You took us through so much there. I wanted to make sure that people did have that opportunity to follow up, because, we're running out of time. Any final point you'd like to make for us?
Maybe that you should not go with like overusing your bash script, and then if you have a chance, then go to those slides at the perk.pl. You have the slides, or slides.com/perk. There is this presentation. Go and see all of those tricks, and please use them, because they help.
That's brilliant. Thank you. Well, thank you all very much for attending the observability and security track on DevOps Pro Europe this year. We hope to see you all again at the next sessions. Stay online for the keynote at 20 past the hour. But in the meanwhile, thank you, Perk, for an excellent session. Thank you very much.
Thank you. Thank you, everyone, and have a great day. Thanks, Ingvar.